नमस्कार। इलेक्ट्रिकल इंजीनियरिंग के ई लेक्चर की सीरीज़ में आपका स्वागत है। आज हम सब्जेक्ट कोड EE-302 यूटिलाइजेशन ऑफ इलेक्ट्रिक पावर एंड ट्रैक्शन के टॉपिक इलेक्ट्रिक हीटिंग के बारे में डिस्कस करेंगे। So basically there are two types of electric heating. First is power frequency heating and second is high frequency heating. In power frequency heating there are two types of heating. First is resistance heating, second is arc heating. Whereas in high frequency heating there are three types of electric heating. First is induction heating, second is dielectric heating and third is infrared heating. So first of all we will study about the resistance heating. In resistance heating, the heating method is based on I square R losses. In this method, electric current is passes through the body to be heated. Whenever a current is passed through a resistor material, heat is produced because I square R losses are created. The generation of heat is done by electric resistor carrying current which is flowing through the conductor. There are two types of resistance heating. One is direct resistance heating and second is indirect resistance heating. So first of all we will discuss about the direct resistance heating. In direct resistance heating, electric current is passed through the body or charge to be heated. जिस बॉडी को या चार्ज को हमको हीट करना है, करंट उसी बॉडी के अंदर से फ्लो करेगा. In this method, the heat is produced by I square R losses. जब किसी कंडक्टर में से करंट फ्लो होती है तो उसके रेजिस्टेंस की वजह से उसके अंदर लॉसेस होते हैं. वो लॉसेस हीट के रूप में हमको मिलते हैं. Direct resistance heating method of heating has high efficiency because the heat is produced in the material or charge itself. So इसकी efficiency high होती है. और this principle of heating is employed in resistance welding और इलेक्ट्रोड बॉयलर और हीटिंग वाटर. इन सभी के अंदर इसके प्रिंसिपल को यूज़ लिया जाता है. नाउ जैसा कि डायग्राम में दिख रहा है, दिस इज़ द सिंगल फेज डायरेक्ट resistance heating. In this method, the material or charge to be heated is treated as resistance and current passes through it. The charge may be in the form of powder, small solid pieces or liquid. The electrodes are inserted in the charge and connected to either AC or DC supply, which is shown in the figure, where two electrodes are placed. One is the positive electrode and second is negative electrode, and DC power supply given to the electrode, and the body or charge which to be heated is placed in this chamber. In case of DC or single phase AC supply, two electrode will be required, while in case of three phase supply, three electrodes will be used. So when we give the DC supply to the electrode, the charge is in the form of small pieces or in form of powder of high resistivity material is sprinkled over the surface of the charge to avoid short circuited, and heat is produced when current passes through the charges. And जैसे हम पहले डिस्कस कर चुके हैं कि दिस मेथड ऑफ हीटिंग हैज़ हाई एफिशिएंसी बिकॉज द heat is produced in charge itself, and the heating method for direct resistance heating is employed in salt bath furnace, resistance welding, electrode boiler for heating water. Now next type of resistance heating is indirect resistance heating. In this method, the current is passed through a high resistance wire from the charge or wire known as the heating element. The heat produced due to I square loss in the element in the transmitted to the body to be heated by one or more mode of heat transfer like conduction, convection and radiation. In indirect resistance heating, electrical current is passes through high resistive material. Mode of heat transfer is conduction, convection or radiation. This method of heating is used in room heater, bimetallic strips, immersion water heater, various types of resistance oven, for industrial purposes where a large amount of charge is to be heated. The heating element is kept in cylinders surrounded by jacket containing the charge. This arrangement provides uniform temperature control or uniform temperature supply. Now next is what are the properties of good heating element for the resistance heating. So we will talk about the properties of good heating element. First of all, the resistance of element should be high, and so it should be keep high specific resistance. It have high melting temperature. It should have low temperature coefficient or resistance, and it should have high oxidation temperature. And next is it should have positive temperature coefficient of resistance. Next is sixth is high ductility and flexibility, and next point is high mechanical strength of it, because every heating element with passage of time breaks open and become unserviceable. Some of the factors responsible for this failure are first is formation of hot spot which shine brighter during operation, and second is oxidation, third is corrosion, fourth is mechanical failure. Now the next topic is arc heating. When voltage is applied between two electrodes separated by small distance is in air gap is increased, a stage at which the air gap between electrodes get ionized and acts like conducting. Hence current flow between the electrodes in the form of continuous spark called arc. जब दो इलेक्ट्रोड के बीच में एयर गैप होता है और हम वोल्टेज की वैल्यू इतनी बढ़ाते हैं कि जो एयर गैप आयोनाइज हो जाता है और उसके बीच में कंडक्शन चालू हो जाता है, तो उससे स्पार्क जनरेट होती है और ये स्पार्क को हम आर्क कहते हैं. Now The self-sustained discharge of electricity between two electrodes through air known as the electric arc. This is another definition of electric arc. On the application of high voltage across an air gap, the air in the gap gets ionized under the influence of electrostatic forces and become conducting medium. Then current flows in the form of a continuous spark. This is known as the arc. When electrodes are made of carbon, graphite, and the temperature obtained in the range of 3000 degrees Celsius to 3500 degrees Celsius. In arc heating, the high voltage required for striking an arc can be obtained by using a step up transformer feed from a variable AC supply. So there are two types of arc heating. First is direct arc heating and second is indirect arc heating. Next topic is direct arc heating. Arc is in this type of arc heating, arc is established between the charge and the electrode, and the heat is directly conducted to the charge, which charge are absorbs. And arc heating is consist of carbon or graphite electrode, and the power is controlled by adjusting the arc length by moving electrode manually or automatically. Means that if we have to control the arc process, we have to vary the distance between two electrode. हम उनको मैनुअली और ऑटोमेटिकली मूव करवा के आर्क लेंथ को कम और ज़्यादा कर सकते हैं. In this type of direct arc heating, this is the diagram of direct arc furnace. In this type of furnace, arc is formed between the two electrode and the charge is such a way that electrical current passes through the body of the charge. We can see in the figure there are two electrodes are placed and power supply is given through the transformer because we need high voltage, and the charge is placed in a chamber, and when the current passes through the body of the charge, then arc will be generated. But such furnace produce very high temperatures, and this is the single phase direct arc furnace. Now next is indirect arc heating. In an indirect arc furnace, furnace arc is formed between two electrodes above the charge, and heat is transmitted to the charge by radiation. Arc is formed between two electrodes and heat is transmitted to charge by radiation. Means that जो arc two electrodes के बीच में प्रोड्यूस होती है और जिस चार्ज को हमें हीट करना है वो रेडिएशन के हीट ट्रांसफ़र प्रिंसिपल से वो हीट होता है. दिस इज़ द लोअर टेम्परेचर देन direct arc furnace, and it operates at 0.85 power factor lagging. Have to provide rocking motion through a motor to distribute heat uniformly. And this diagram is represent the indirect arc furnace. Diagram shows a single phase indirect arc furnace which is cylindrical in shape. The arc is struck by short circuiting the electrode manually or automatically for a moment and with withdrawing them apart. The heat from the arc and the hot refractory lining is transferred to the top layer of the charge by radiation. The heat from the hot top layer of the charge is further transferred to other part by the conduction. So in this diagram we can see that there are two electrodes are placed which can be moved automatically or manually, and in this type of furnace, since no current passes through the body of the charge, there is no inherent string actions due to electromagnetic forces set up by the current. Hence, such furnaces have to be rocked continuously in order to distribute heat uniformly. Next, by exposing different layers of the charge to the heat of the arc, and in this furnace, since charge is heated by radiation only, its temperature is lower than the obtained in direct arc furnace. Now, what are the advantages of indirect arc furnace? The first is lower overall production cost per ton of molten metal. Second is sound casting in thin and intricate design can be produced. Third is metal losses due to oxidation and volatilization are quite low. And fourth is flexible in operation. Thank you.